All right. So hello, everybody, and thank you for joining us for the AWS Data Exchange Activation Day. We are super excited to have you here, and it's great that you all could join us today for this workshop. My name is Uday Narayanan. I am part of the AWS Data Exchange team, and I'll be a moderator for today. The topic for today's Activation Day is modernizing geospatial data analysis and visualization with AWS and Foursquare. So data is at the forefront of every decision that an organization makes. Leveraging only the first party data that you own might not always be enough, to get deeper level insights that you're looking for. So augmenting your first party data with third party data can further enhance the insights that you can gain to help achieve your business outcomes. AWS Data Exchange makes it easy to find, subscribe to, and use third-party data in the cloud. During today's workshop, you will get a comprehensive understanding of how businesses are leveraging AWS Data Exchange for Amazon Redshift and Foursquare Studio to gain competitive advantage, make better decisions, drive growth, all of that by utilizing geospatial data. So let's look at the agenda for today. So we will start off by giving you an overview of Foursquare and its capabilities. We'll then do an overview of what AWS Data Exchange is, diving deeper into the technology and our data delivery mechanisms, making sure that you understand the most important concepts. Then we'll deep dive into AWS Data Exchange for Amazon Redshift delivery method. Finally, you will get your hands on keyboard to start experimenting a bit with the service. Here, you will understand how AWS Data Exchange, Amazon Redshift, and Foursquare Studio are leveraged to visualize and gain insights from spatial data. And finally, we'll wrap it up and talk about next steps. Now, some things to know before we get started. We expect this workshop to take around 2 hours and 15 minutes, and we'll have a break halfway through the session. Now, I'd suggest you take a few seconds to familiarize yourself with the GoToWebinar pane, because there are a few functionalities that we'll be using today. You will find the slides for today's session in the handout section of the GoToWebinar pane that you have. And then as we go through the session, any relevant links that we want to share with you will be posted in the chat section. If you have any questions, you can use the questions pane. We have our speakers and support staff monitoring the questions section, and will be able to answer any questions that you have. I also want to do a quick reminder of the prerequisites for the hands-on lab. This was shared on the registration page as well as in the confirmation and reminder emails, but I want to make sure that we go over it once more. You will need an AWS account with the right set of permissions to subscribe and import AWS Data Exchange data to Redshift. To access Foursquare data, will give you a temporary access to the FSQ Studio. And you're expected to have some sort of familiarity or basic familiarity with SQL. With that said, if you do not have an AWS account, you can still watch the session and still get a lot out of it. All right, so this is the AWS team that is going to be working with you today. So my name is Uday Narayanan, as I had said earlier. I am the moderator for today. And then we have Chelsea, Saurabh, and Soheb, who are all analytics specialist solutions architect at AWS. And you'll be hearing from them during different parts of the session today. We also have Nick Rabinowitz, who is a senior staff software engineer at Foursquare. He will talk about Foursquare's capabilities and provide you with an overview of Foursquare. Then for the lab section, we will have Venkatesh and Chidambaram, who are our lab supporters. They will be available to help address any technical challenges you might face during the hands-on lab section. Now that you know who we are, let's get to know you. So can we have the first poll, please? Yeah, so basically just trying to understand, what your role is in your organization, and if, you choose the other option, uh, if it will be good if you can, in the chat, just share what role you have in your organization. All right, we'll give it another, let's say, 15 seconds. All right, cool. So we have some data scientists, we have data engineers and data architects as well, and then 55% are others. And in the others, I see there are some consultants, there's a media buyer, we have business analysts. So yeah, I mean, there's a good variety of roles here. And, I'm sure all of you will get some important concepts and important value out of this session. So it's great to see a good amount of variety here. So that's nice. All right, we have another poll. Can we have the second poll, please? So yeah, this is just for us to understand how familiar you are with AWS Data Exchange. Have you worked with the service before, or if you are brand new? So just trying to get an understanding of how familiar you are with the service. All right, let's give it 10 more seconds. Okay. All right. Let's see. Okay, so there is nobody who's super familiar, which is great. So, and there are some people who have some sort of familiarity with it, and then not familiar at all. We have. So yeah, I think this is great because we are going to talk about some basic concepts of AWS Data Exchange. So that will be really good for the folks who are not at all familiar with it. But then, as we go through, there'll be like some hands-on experience as well. So even for the folks who are somewhat familiar, there's going to be some valuable learning today. All right, great. So I think we have a good variety of folks who have attended the session today. With that, I'm going to hand it over to Nick. So Nick, over to you.
Thank you. I'm going to give a quick overview of Foursquare. And first introduce myself a little bit. So hi, I'm Nick. I'm a senior staff engineer at Foursquare, where I work on Foursquare Studio, which is our flagship geospatial analytics application. Prior to joining Foursquare, I spent about 5 years as a software engineer at Uber, where I worked on a variety of geospatial applications, and I helped to launch the open source H3 library, which you'll see some of today. So you may know Foursquare from our early days as a check-in app. That's certainly how I knew Foursquare when I first joined. But today, Foursquare is the leading geospatial technology platform, providing data and geospatial applications that'll help you better understand the world around you. Our background in consumer apps, the kinds of things that we used early on in our history, gave the company a deep understanding of movement and places. We can use technology to understand where things are and how people move throughout the world. And our tech stack helps businesses to use location to make more informed decisions and ultimately to drive success. So Foursquare leverages our technology and our deep background in location data for our geospatial platform. We have some of the most accurate and trusted location data in the world, and our customer-facing applications enable advanced geospatial analytics and powerful visualizations. Foursquare provides a combination of high-quality geographic data, particularly around places, with powerful analysis and visualization tools. And this allows you to explore your data and identify geographic patterns and insights. Our up-to-date data set of global places has over 100 million points of interest across 200 countries and territories. And the data is consolidated from a range of sources, including ground truth data from consumer-facing applications, and then goes through a pretty rigorous process of cleaning and updating. We make over 2 million updates per month to keep the data set fresh. For example, identifying where businesses have closed or when new business locations open. You can access free samples of this data right now in the AWS Data Exchange, which is really what we're here to talk about. We also offer a range of solutions for geospatial analysis, and foremost among these is Foursquare Studio. So using tools like Foursquare Studio, you can quickly bring diverse data sets into one place. You can display them on the same map, you can join them, and you can use them to answer key business questions. So find out where your business is performing well, where it's performing poorly, where should you put your next location, where should you focus your ad buys. Even really lightweight geospatial analysis can help to quickly inform these decisions. And we've tried to make a tool that is applicable for people who are not GIS experts, but can perform many of the advanced techniques that you can do in expert GIS tools. Hopefully that gives you a quick overview of Foursquare. And with that, I will hand it over to Chelsea.
Good morning, everyone. My name is Chelsea Ip. All right, you can see my screen. Great. Good morning, everyone. My name is Chelsea Ip. I'm an Analytics Specialist Solutions Architect here at AWS. Today, I'll give you a high-level overview of AWS Data Exchange and highlight some important concepts as we go along. Let's talk about why exchanging data is so difficult and time-consuming today. Industry leaders and the world's most influential companies are using unprecedented volumes of data available today to innovate and grow. This is both the data that's generated in-house from, for example, ERP and CRM systems, and third-party data that you can use to enhance analytics and machine learning, such as weather patterns or market data. However, according to McKinsey, comparatively few companies have realized the full potential of linking internal data with data provided by third parties, vendors, or public data sources. And one of the reasons they cite is that just understanding what's available requires significant effort given the sheer number of data sources available. Customers can drive real value, profit, by becoming data-driven. But what slows down the pace of innovation is the fact that data teams spend up to 80% of their time on sourcing and preparing the data for use, instead of doing the business differentiation task of actual data analysis. And so why is that? Because finding the data that you need, getting it, and preparing it for use is time-intensive, labor-intensive, and just plain difficult. A lot of the world has changed over the past 20 years. But our primary methods for exchanging data have not. Cloud has enabled customers to build applications, perform analytics, and deploy sophisticated machine learning, all cheaper, better, and faster. But anytime the business depends on third-party data, it typically relies on the old way of doing it. Those looking to procure data to make better decisions have to do a lot of research to see where the data is sourced from, call potential providers, solicit samples, validate them, try to understand terms and pricing, and then set up the integration with their environments because it might come through SFTP, an API, a DVD, or even a hard drive. And once they license it, engineers have spent over weeks to months of time building pipelines to ingest, validate, and transform the data before they can start using it for applications. In the same way that machine learning or application development has been simplified and democratized with cloud technology, exchanging data should be too. Finding, preparing, using data on the cloud, where more and more of it is being generated and stored, should be easy. Subscribers should have a place where they can go to procure all of the data that they need in whatever format they need it in. They shouldn't need to jump through hoops to set up subscription, contracts, and billing. And they shouldn't need to invest months of effort building pipelines to prepare and load data into their production systems each time they license new data. AWS is the world's most comprehensive and broadly adopted cloud platform. So we launched AWS Data Exchange to bridge the gap between providers and subscribers exchanging data, helping customers lower costs, become more agile, and innovate faster. We help organizations find the data they're searching for with our comprehensive catalog, including over 3,500 public products from over 300 data providers. We also support custom and private products for situations when customers want data that is not in the public catalog. We have over 1,500 free public data products for customers that want to try before they buy and support private data trials as well. And we also support data delivery via files, tables, and APIs, so customers can start using the data as soon as they want it in production. So now let's talk about technology. AWS Data Exchange makes it easy to use data because it is natively integrated with AWS. Customers can choose to ingest third-party data files, whether directly into S3. They can also choose Amazon Redshift tables, letting the providers handle the work needed to cleanse, validate, and transform the data into production-ready tables. They can also ask for data delivery via APIs, letting their developers start integrating the data into production applications wherever they are built. Because security has always been AWS's #1 priority, AWS Data Exchange is a secure and compliant way to exchange data. As all data is encrypted and at rest and in transit, and AWS Data Exchange is also integrated with AWS Identity and Access Management to create fine-grained controls using IAM policies. Now, to the business side of things. AWS Data Exchange provides one place to exchange data publicly and privately. Today, hundreds of data providers make thousands of different data products available to the millions of AWS customers worldwide in our public catalog, or privately to individual customers of their choosing. Subscribers can browse our public catalog on the AWS Marketplace or accept private offers with bespoke content, commercials, or terms. And of course, it simplifies subscription and billing management. Customers can migrate existing subscriptions to AWS Data Exchange at no cost. Last but not least, any fees for commercial data products are consolidated on the customer's AWS invoice, saving subscribers from having to set up and manage yet another billing relationship. For subscribers, all of it means spending less time searching for data, public infrastructure to get it, building infrastructure to get it into production, and ensuring the data and delivery is compliant with industry regulations. Instead, your engineers, analysts, and scientists can start using the data as soon as you license it. So what happens when companies have easy access to third-party data and can put in the work quickly and easily? Let's look at a variety of industries that are using third-party data from AWS Data Exchange to enhance their analytics and machine learning pipelines. For example, pharmaceutical companies are using life expectancy benchmarks data to research new drugs. Retailers are leveraging weather data to anticipate customer needs and optimize inventory planning. Academic researchers are conducting climate change studies by subscribing to carbon dioxide emissions data. Restaurants are subscribing to location data to identify places to expand. Asset managers are using traditional data and alternative data, such as sustainability scores, to better model portfolio risks. And lastly, property insurers are subscribing to historical weather patterns to calibrate insurance coverage in different geographies. There's no other place where customers can find data files, tables, and APIs in one place. When we launched AWS Data Exchange in 2019, we launched it with the most requested delivery type functionality, version file-based datasets. Once the dataset is exported to S3, customers can use AWS services to transform it into tables for use with analytics and machine learning services to get insights out of the data or integrate it with third-party tools, and software like Tableau or Domo. In 2021, we launched data delivery via Amazon Redshift and API. With AWS Data Exchange for Amazon Redshift, subscribers get access to live or ready-to-use tables that they can query and analyze in Amazon Redshift with no file ETL required, or easily ingest it into other database services. With AWS Data Exchange for APIs, customers can now integrate third-party data into any of their company's software via API requests without ETL. And in the spirit of innovation, we have two new delivery methods available to you: AWS Data Exchange for Amazon S3 and AWS Data Exchange for Lake Formation. It is launched at the end of 2022 at reInvent. AWS Data Exchange for Amazon S3 enables customers to easily find, subscribe to, and use third-party files directly from the data provider's S3 buckets. AWS Data Exchange for AWS Lake Formation offers data providers license access to live, ready-to-use structured tables, for example, AWS Glue tables via AWS Lake Formation. Since launch, we have continuously released new features based on customer feedback that make it easier for customers to find, subscribe to, and use third-party data in the cloud. Let's talk about the basic constructs of AWS Data Exchange. AWS Data Exchange data product have three primary components. First, product details, data sets, and offer. Each product can either be listed in the public catalog or they can be privately offered to specific AWS accounts. The metadata contains information like name of the product, logo, sample files, and so on. Data in AWS Data Exchange is organized using three building blocks: asset, which is a piece of data; revision, which is the snapshot of a data set; and finally, a data set, which is the logical grouping of the data which you can subscribe to. A product is then made up of one or more data sets. The final dimension of a product is the offer. Providers can offer their product at terms that are different from the publicly available offer terms. A private offer can be different from the public offer in any dimension, including price, duration, payment schedule, data subscription agreement, or refund policy. These three building blocks form the foundation of the product that you can manage using AWS Data Exchange Console or the AWS Data Exchange API. Now let's talk about how it looks like when the subscriber subscribes to the data. It starts with the data subscriber discovering and requesting products. They can review at the product details, look at the data delivery method, contract terms, sample. They can also request for a private custom offer. Then this is an optional piece, but it's very important and it's frequently asked by our customers, the governance piece. Providers can control which products can be procured with private marketplace, and the data subscriber can control user access with IAM policies. Then, as a data subscriber, you can choose to subscribe to a public offer or accept the private offer in the console. And then there's another governance piece, which allows the data subscriber to disperse entitlement within their own organization with license manager. Finally, they can access their data sets. They can export the file to S3, query Redshift table, or call the API. They can also set up auto export for new revisions. They can analyze. They can further use AWS analytics and machine learning services to get insights out of the data. And of course, all of the billing is consolidated on your AWS invoice. Now I'm going to hand it over to Saurav to go into AWS Data Exchange for Amazon Redshift. Thank you.
Thanks, Chelsea. Let me share my screen. Yeah. So yes, my name is Saurabh Shanbag. I'm a Senior Partner Solution Architect covering data analytics partners at AWS. And we got a great overview around AWS Data Exchange and all the delivery methods. I'll be taking a deeper dive into one of those delivery methods here, which is using data shares in Amazon Redshift. But before we take a deep dive there, I want to focus on what is Amazon Redshift and why did we actually bring out a service in that domain. So our customers have always been asking for an alternative to traditional data warehousing. As data volume and velocity of the data has been increasing across various customers, they are seeing that using the traditional on-prem data warehouse solutions is not keeping up with the volume and velocity of data. Moreover, they see that those solutions are costly and come with complicated license terms, and even at times harder to tune and work at scale. So at a lot of these customers, what happens is the data is segregated in different silos. And that's where customers reached out to AWS around how we can solve that problem for our customers. So Amazon Redshift has been out there for 10 years now. We listened to our customers and launched this service uh, towards the main capability of getting a fast, fully automated petabyte scale data warehouse solution to address the same problems which customers were facing on-prem. So it is optimized to scale right from the range of few hundred gigabits to petabyte scale. Moreover, because AWS has built this on as a cloud native service, it is simple to get started with. It is very cost efficient, and at times it can bring up 5x better price performance from some of the traditional workloads which customers are running on-prem. I also want to focus on 4 key innovation areas that Amazon and AWS have worked towards differentiating Amazon Redshift from traditional on-prem data warehouses. So first of all, I want to say the focus is on no more data silos. We want customers to have the ability to analyze all their data. And now we know that transforming the data, you don't have to transform the data and move it over into a data warehouse through a complex ETL process. With Amazon Redshift, you can easily analyze all your data. Let's say if you have created a data lake, we want to let you take advantage of that data lake and query that data lake right from Amazon Redshift. And all this can be provided through Amazon Redshift by a consistent security and governance policy. So you don't have to use custom solutions out there. So second, so the focus is on provide fast performance at scale, and that too while optimizing cost. So with Amazon Redshift, we are able to deliver up to 3x better price performance compared to other cloud providers. We have some benchmarking reports which were done for data warehouse sync solutions, where we were able to validate that, as well as how we were able to achieve this is two key initiatives. One was to keep the compute and the storage separate. That way, when we have to scale, we can scale each, let's say, compute or storage independent of each other. So as you can scale your storage, you have to only pay for what your needs are on the storage layer. Another key factor is automation. With Redshift, there's a lot of self-tuning and self-learning. So the Redshift system itself would be able to define sorting based on the usage, would be able to distribute the keys based on your usage of your workload. Even new capabilities around creating materialized views or auto refresh or even auto query rewrite would be done by the various automation process in Amazon Redshift. And this leads me into my third point here, which is easy analytics for everyone. By providing a fully managed data warehouse and abstracting away the infrastructure management, performance optimization and tuning, users can now focus on getting insights. They don't have to worry about maintenance tasks around backups or operation management. And finally, we understand that protecting data is very important for our customers. It's the same here at AWS. Security, we consider it as our job zero. With Redshift, we provide built-in security methods. So you don't have to spend time building custom solutions to monitor and protect your data. You can leverage various security methods like placing your cluster in your VPC, enabling encryption on the data, even using row-level security. So there are various security methods, and we are doing more innovation in that space to meet all your compliance needs. Now we go a step ahead here, with Redshift serverless. With Redshift serverless, you don't have to worry about scaling or setting, the size of your compute cluster to get started when you work with analyzing your data. So anyone can get started in seconds here, and Amazon Redshift would automatically and intelligently provision capacity. So let's say if you had some workload which were unpredictable or very demanding, you can still bring them to Amazon Redshift and only pay for what you use. So it will scale based on your needs. Yeah, but at the same time, we understand that customers want flexibility and customers want a choice there. So what we recommend for any new customers is they can easily get started by using Amazon Redshift serverless for any new data warehousing workloads needs they have. So they don't have to do the infrastructure management or worry about scaling. But for advanced customers who know what their workload is, or probably have been using Redshift for a while, they can still go with the custom provision environments and exercise granular controls that fits their need. So this brings me to AWS Data Exchange, and what value does it bring to analytics on the Amazon Redshift? So Chelsea did cover all these various different methods offered by AWS Data Exchange, like file tables and the data APIs as well. We are diving deep into the Amazon Redshift delivery method here, which is highlighted in yellow. So now let's talk, why and how the customer or subscriber of the data exchange product going to see value by bringing in the third-party data onto that Redshift cluster. So first of all, we see that the core value which a third-party product brings is we are able to query that data, analyze it, and do the analytics with production-ready third-party data right into the cluster. So you don't have to actually perform ETL, bring in data files, do some transformations, and then bring it to Redshift to do these queries. Again, by bringing in core value from third party, you can enrich your first party and get real insights which can drive great business decisions. On even when you're working with this data, we do support cross-region data sharing. So your provider and the subscriber can be in different regions as well. Even when you don't have your data in Redshift, let's say it's in a data lake, you can bring in third-party data onto Redshift and query your first-party data on a data lake, or even use federated queries to query data on Amazon RDS or Amazon Aurora without need of ETL. So it brings great value there that you can query all that data from one point of source. And because the data providers can provide this data through Redshift, most of the data validation and cleansing is already done for the subscribers. So it provides added benefit that it is production ready and customers can use it immediately. At the same time, once it lands into Redshift, we can have various downstream processing, which can be sent through unloading table command from Redshift onto S3, or even use AWS Glue to stream data from Redshift into other source systems, other downstream systems. Another thing I want to bring focus to is data sharing. So we did talk about, okay, the subscriber is sharing the live production ready data. So there's no two different copies of data here. What we are talking about is a single copy of data, which is shared across different clusters and even cross account. So even in our organization, we have this capability where, let's say, if you have different organizations here, as you can see, finance, sales, marketing, data science, and they are using different technologies around serverless and provision clusters. But now with the capability to securely share the data, the same copy of data can be shared across these different departments securely based on your governance. And these don't even have to be in the same region and can be cross account as well. Okay. And the other advantage is subscriber only, specifically only pays for the compute because we are working with a single data share here. So tens of thousands of our customers use Amazon Redshift. We are working with large customers here, like if you see NASDAQ, who bring upwards of 10 billion records into their data lake, and then they leverage Redshift Spectrum to join that data with the local data on their Amazon Redshift cluster to get real-time insights. We see that Magellan RX uses Redshift ML, so they were able to actually bring their data warehouse onto Redshift, see a operational cost reduction by upwards of 20%, and then even use the machine learning capabilities on Redshift to give predictive analytics, and we're able to forecast the drugs cost and even identify trends there. We also see that game developer companies like Zynga were able, which work with over 70 million users, were able to migrate their data warehouse to Amazon Redshift, use the core capability there around separation of compute and storage, and migrate over 5 TB of data daily. So that was the amount of migration. They're using ETL processes, and they saw that the ETL performance actually improved to the orders of magnitude of 2 when they moved over to Amazon Redshift. So the core benefits here on the AWS Data Exchange is I would like to bring about as one is you don't have to worry about ETL. The data is always production ready. Yeah, and you can query directly on the vendor's database. So there's only a single source of truth. You don't have to worry about data quality or any errors in the ETL layer. The query can be across regions, so your data can actually traverse across regions, and you only pay for the compute. So let's say the amount of storage is pretty large, like let's say a provider is providing you a large set of data, but you still don't have to pay for the storage. You just have to pay for what you use on the compute side. With this, I will hand over to Shoaib to cover the hands-on lab section, which we bring focus to Amazon Redshift and Foursquare today.
Thank you, Saurabh. Now I get the pleasure of introducing the part that you've all been waiting for, the hands-on lab. So my name is Sohaib. I'm an analytics specialist solutions architect. I'll be starting off and kicking off this lab for us, and then Nick, who you heard from earlier, in our presentation, he will be continuing on with the lab and show you how to use Foursquare Studio. So we will do the entirety of the lab will complete after a short break. But before we take a break, I want to get us started and get going with some of the prerequisites so that we're ready to go whenever we come back from the break to kind of dive into the Foursquare Studio portion. So to do this, I'll give you a link in the chat that takes you to the workshop. I see that Enza's already posted that. Awesome. So that will take you to the workshop page that has the instructions. But in addition to that, I will also give you, another link that'll take you directly to the AWS Data Exchange Marketplace, where you can see the data product. And I will post that as well. There we go. Okay, so how do we get started? Before we do this, jump into it, I just want to say, I will go over the demo, Nick will go over the demo to show you each tasks and how to do them in the AWS console or in the Foursquare Studio tool. And you can replicate the same steps on your own at the same time. We have all the tools and capabilities available for everybody in the audience to follow along. So if you want to, if you prefer to follow along, you absolutely are able to do so. Or if you want to just, kind of watch and learn as a demo, you're free to do that as well. But all the steps are available in the instructions page that we posted in the chat as well. So you can definitely, follow those instructions if you feel like we're going at a different pace than you would like, if you want to look ahead or if you want to catch up, if you feel like you're going a little bit slower. If you do get stuck at any point in time and you need some extra help, we have a breakout room on Chime. You can see on the screen here, it says our lab supporters are there to help you in this Chime room. The link to this Chime is also in the chat. So if you have any questions or if you need some one-on-one help, you can definitely click on that in a separate breakout room, and our lab helpers will be able to help you. Okay, so with that said, we did have some prerequisites published for the attendees if they want to be able to follow along, but we've actually made it even easier than some of these things listed here. So even if you don't have an AWS account, I can show you how you can still browse the AWS Data Exchange catalog. And if you do have an account, that's even better, because then you can actually subscribe to the data product that I will be showing you. All right, so with that said, I'm going to switch over to an internet browser. I'm using Firefox here, but you can use Chrome as well. And so the first thing I want to show you is how you can easily get started and find this data product in the AWS Data Exchange Marketplace without needing to even have an AWS account. So this is a link that I posted earlier. I will again post it here so you can go straight to this page. I've already kind of filtered it down for Foursquare. So you'll see a list of 34 products listed here, all from Foursquare. And this requires no account. So you can see here, I'm not even signed in, and I can browse the entire catalog. I can filter, I can search for additional things. So what we will specifically be using for this lab is the Greater Atlanta sample, which is Redshift accessible. You can either scroll down and find it, or you can search for Foursquare followed by Atlanta, and that will filter it just to that one specific one that we're interested in. And this trial data set contains the Foursquare places database or points of interest for the Greater Atlanta area, and it's accessible as a Redshift data share. I will click into that, and I can see some additional details about this product. I can see that this is available for an offer of $0 for 3 months. So I can test it out and sample it. I can see an overview of the data set, and it shows me what it contains, such as 130 million plus points of interest across 200 countries. The full schema, including descriptions of the data, can be found in this link. So I can, if I want to explore more about what is in this data set, I can click there, and I can see some additional details here. So if you do have an account, you can continue to subscribe. You can click this button. That'll open a link into your own AWS account page. so I can show you what that looks like. I will actually go here. Now I'm logged into my account, and I'm going to click on that same product. So when I click on continue to subscribe, it takes me to a subscription request page. I can verify the subscription terms and make sure I agree to it. I can see that this includes this data set. And then I fill out a short form that provides information to the provider. In this case, that'll be Foursquare, as to who I am and what I would like to, I'm requesting to try out the sample data set, what I would do with it. So I'm going to put my name in here. And I put in my email address and my intended use case. Here I'm just saying I'll be demonstrating it, but I can say I will follow along with the workshop. And then I can send a subscription request to the provider. So once I've clicked that, I can see that it has successfully created a subscription request. And now I can see on the left-hand navigation pane of my AWS Data Exchange, I can see it under subscription requests. So the status is pending review by provider. This typically means that my request will go to Foursquare, and then the provider will approve it. And then once it's approved, then I'm able to use this data and associate it with my Redshift instance. Okay, so for the portion of this lab, we've already created a Redshift instance that is shared. We've already attached this data set to that Redshift instance, so you don't have to do that. Just like a cooking show, we've already kind of put it in the oven beforehand, so it's ready to go. So we can kind of jump right in. I just want to show you one more thing before we take a break. The lab instructions that ends up posted in the chat will take you to a page that looks like this. This page includes an overview of what we'll be covering. Nick will also go over this after the break, so you don't have to worry about it right now, but he'll give you an overview of what we're trying to do, what is the business use case for this lab, what's the background and context, and what we're trying to achieve. And then he'll also walk over this architecture. And then also, if you were not able to follow along with me on what I did, there's also instructions on how to find and subscribe to Foursquare data from AWS Data Exchange listed here that goes through all the same steps that I just went through so that you can follow it at your own pace. There's a link to open the same catalog page in your browser, and then you can search for Foursquare Atlanta, which I already showed you how to do. And then you click on this specific data set and you can continue to subscribe and follow those steps. And then the rest we will cover after the break. And hopefully you're able to see how easy it is to find and subscribe to the Foursquare Places data in the AWS Data Exchange. And then after our short break of around 15 minutes, we will continue on and Nick will take over and walk you through logging into Foursquare Studio and continuing on with the rest of the lab. So if you want, go take a quick water break or check your email messages, etc. And we'll take a 15-minute break at this point.
Right, thanks, Sohaib. Yeah, so we'll be back at 10:05 Pacific or 1:05 Eastern time, so 15 minutes from now.
Hello, welcome back from the break. This is Nick Rubinowitz again from Foursquare, and I'm going to get us started with the hands-on lab using AWS Data Exchange and Foursquare Studio. So I mentioned Foursquare Studio earlier. Foursquare Studio allows you to easily explore, visualize, and derive insights from geographic data. It supports a pretty wide variety of data sources, including flat files from your desktop and cloud sources like Amazon Redshift. In this exercise, we're going to use Studio to explore market analysis for a fictional food delivery company. So the term market analysis can mean a lot of different things to different people. This is probably a relatively limited scope of market analysis, what we're going to do in a short hands-on lab, but hopefully it'll give you a taste of how to use a tool like Foursquare Studio to do market analysis based on geographic data. Our hypothetical scenario here is that we work for an up-and-coming food delivery company, which we'll call Door Eats. I made that name up myself. Thank you. Thank you. We already work with several restaurant chains in the Atlanta region, and we're looking to expand. And so we're going to use Foursquare Places data in Foursquare Studio to answer some of the following questions. We're going to look at what is the total addressable market in the region. So what's the total number of households we could potentially reach with our food delivery service? We're going to look at our total serviceable market, which is to say, given our current chain partnerships, what are the households we can currently reach, given the geographic spread of those restaurants we already work with? And then we're going to look at what new chain partnerships will add the most households to our serviceable addressable market. So making some kind of business decision about who to partner with based on this geographic analysis. So please note, we are using real data in this exercise. So we'll be referring to real restaurant chains and their actual locations, but we're not implying any kind of affiliation or any real world interaction with those restaurants. So let's get started. To get started, you can go to studio.foursquare.com, and we will, here, I will paste the username and password that we want to use in the chat. So you'll be able to sign in with this username. You'll be able to sign in with that password. We are all going to use the same username and password for the purpose of this workshop. And this will just be an easy way to get us all started in this lab. So when you get to Foursquare Studio, you'll see the homepage, which looks like this. It doesn't have much on it yet because we haven't logged in. So the first thing we're going to do is log in. We can log in either with the button up here or with this big button right in the middle of the page. I'm going to use the same username and password that I shared in the chat. I'll just cut and paste that in. And now I'm logged into my account, and I can see some of the maps that I've recently made, and I can see some of the other information about myself here. My exciting name, ADX user. If we click on Workspace in the top of the navigation bar, this is where you have access to everything that you, all your assets or resources that you've created in the Studio platform. So these include maps, which we can make in the Studio interface. That's where we'll spend most of this lab. It also includes data sets, which we can upload from a file or we can create through data connectors. It includes the data connectors themselves, which allow us to connect to cloud sources like Amazon Redshift. So as Sohaib mentioned earlier, we have pre-baked the data connector. This is going to make the following along with the lab much easier. But just to give you a sense, so this is the data connector we'll use. If you were going to add a new data connector, you can do it here with this Add Connector button, and you can choose the data source you want to connect to. If we connect to Amazon Redshift, it'll give us a form that we can use to fill out some of our connection details for Amazon Redshift. Everything we put in here, particularly the secrets, is going to be encrypted on our servers and used to access your Amazon Redshift account as needed. So we can give it a name, my Redshift connector. We can give it a description. We will fill in the access key ID and the secret access key that you get from your Amazon Redshift account. Cluster ID, which may or may not be necessary depending on whether you're using Redshift serverless. A database name and a database user, the region you want to work with, and then usually you'll want to use the temporary results cache, which should speed up your queries. I won't go through here, but usually if you were setting up a connector, you would then test the connection, you'd make sure that it worked, you'd hit confirm, and then you would have a connector ready. So let's assume, for the sake of this workshop, that we've done that. We've created this particular connector, which connects us to the same Foursquare Places sample data that you saw earlier in the workshop. The first thing we're going to do with this, the thing that we mostly do in Studio, is to create a new map. There are a couple ways to do this. You can click on the connector and hit Create Map. You can also just click this New Map button up at the top. And I'll do that just to help you to get a little bit oriented to the Studio application. So we have a map here, and immediately the thing it wants us to do is to add data to the map. We're going to move over to Query, where we can select our Foursquare Places ADX connector. And this will get us into a SQL interface that allows us to directly query our Amazon Redshift instance. So to get started, let's start working with some of the Redshift queries we might make. I want to take a quick moment to say this workshop page that was shared earlier and that's shared in the chat, you might want to use this just to get some of the specific SQL queries we'll use. So most of the queries that I use in this workshop, you can cut and paste directly from this workshop page, and that might make it a little bit easier if you don't want to type them all in. So here we are in our SQL interface. This allows us to view our Amazon Redshift data. We can see here we have one table available, the Foursquare Places Atlanta sample. And if you open that up, you can see all of the columns in that table. We may have mentioned earlier, but Foursquare maintains this very rich data set of places information. This spans the whole globe and includes not only basic things like latitude, longitude, name, etc., but also a really wide variety of richer attributes. Things like, whether this is a dressy location, or whether you need reservations to go to this particular restaurant, for example. You can see this is also linked from the workshop page. We have documentation on all of these attributes. So we have a detailed data dictionary here that tells you everything in our POI data set. And we also we'll be talking a little bit about categories later on, because that's one of the most important parts of our POI data set, how to categorize these places. And we have a detailed taxonomy of all of our categories. These are all available at location.foursquare.com/places/docs. And you'll be able to get full documentation of the Foursquare Places dataset. So to get started, let's make our first query. I'm just going to do a simple count so we understand how much data we're working with in the sample. Hopefully everyone who's participating here is at least somewhat familiar with SQL. We're not going to do anything really complex here in the queries. But it'll be useful if you have some familiarity with how SQL works. So we're just going to select a count of all rows from the Places Atlanta sample, excuse me, and we'll hit Run, and we'll get the answer back from Amazon Redshift. So you can see we've got about a little more than 500,000 POIs available in the sample. One thing to note here, you might end up running multiple queries, either in this session or in other sessions. And one way to get these back, if you want to load them again, you can see this query history in the right-hand sidebar. That's a really nice way to be able to load in a query that you've done before and then start editing it and iterating on it for new information. So as I stated at the beginning of this, we are in this hypothetical scenario a food delivery service. And so what we're really interested in are restaurants. One of the things that we have in the Foursquare POI data set is a category ID. We have both the IDs and labels. You can see the attributes here. The IDs are numeric attributes, which you can use, or you can use the labels, which are a bit more human readable. And I'll use the labels in this workshop just to make this a lot clearer and more understandable. So the first thing we're going to do is to select some restaurants. And I'll just select all rows so you can get a sense of what's in there. And I'll use the Foursquare categories. Oops. I'll just get mixed. So I'll choose the Foursquare records where the category label is like restaurant, and that'll pull up a whole bunch of a sample of, in this case, 1,000 POIs that have that restaurant category. We get 1,000 rows back, and you can take a quick look and see the kind of data we're getting back. So we have a unique Foursquare ID, we have the name of the restaurant, we have the latitude and longitude, which will allow us to plot these on a map. We have other additional geocodes that give us more details about things like the roof or the entrance. We have an address, we have the DMA it's in if you're in the United States, and we have a lot more rich attributes, as I noted, including these category IDs and category labels and a variety of other metrics and attributes for each restaurant. So I mentioned, as this part of this hypothetical, that we already, in our fictional delivery company, have partnerships with a couple of restaurant chains. So in addition to the category labels, we also have chain names and chain IDs. This allows us, even if you don't have the exact name of a chain as the name of your restaurant, it allows us to have a normalized chain relationship between different POIs. So in this case, you can see that some of these restaurants are parts of a restaurant chain. And that's what we're going to use to retrieve the restaurants we're interested in. So in our fictional scenario, we already have chains that we are interested in. If you want to get a quick sense of which chains might be available, we can select the distinct chain names from this sample, where the category label is like restaurant. When we run that, we'll get a list of restaurant chains that are available in this Atlanta sample. There's Waffle House, Chick-fil-A, Wingstop, etc. The chains that we have already partnered with in our fictional business case are Panera Bread and Chipotle. As an aside, I used to live in Atlanta. If you live in Atlanta, you almost have to call it Chipotle. I will call it Chipotle nonetheless. So what we're going to do now is we're going to select the actual chain of locations for those chains that we are interested in. And we'll just select a subset of the data. So we'll select the name, the latitude and longitude, so we can plot it on a map. We'll select the Foursquare chain name and the popularity, just to pull out a piece of data that we can look at. We want the category to be restaurant, but we also now want the chain name to be part of our query. This is all fairly standard SQL stuff, but it might be hard otherwise. Without Amazon Redshift, it would be hard to access this directly in a product like Studio. In this way, we have a nice clean interface directly to Redshift, and we can get this data very quickly in our interface and then get it onto the map. So we come back with 121 rows. These are all the locations for Chipotle and Panera. And we're going to add these to the map by clicking this button, Add to Map. So right away, we see these on the map, and we have this set of data directly visible in our browser. I'll take a quick pause here to give you an overview of the different pieces of the Studio interface. So obviously you have the map interface right here that's going to show you, a base map along with any data that you add. We have our data set list over here. And one of the things I really like to do when I pull in data, or even when I start working on an analysis, is to give things meaningful names because it makes things a lot easier. So this is the title of our map. I'm going to call this Atlanta Restaurants. Right here, we have a list of data sets that we're working with in this analysis. Right now, we only have one. It's the data set that we pulled in through that query. It gets a default name that's not very useful. So I'm going to rename this to Our Chains. These are the chains that we care about that are already partners of our fictional delivery company. We also get layers. So layers are different visualizations that are shown on the map. You can have many layers for one data set, or you can have no layers for one data set. And you can add more layers as needed and change the order to get different types of visualizations. So by default, we get this point layer. Again, I'm going to call this Our Chains. And if we open up the settings, we can get a list of available options. There's a lot of visualization options that Studio offers to give you different kinds of visual representations of your data. By default, we colored this based on popularity. I think it might actually be slightly more interesting to color it based on name. And if we're coloring by name, we probably want a different color scale. So we can scroll down here. I clicked on the color scale and we can pick one that might be more useful in this case. Let's pick this color scale, which is a categorical color scale. So we get two different categorical colors. And if we use this radius slider, we can change the size of the dots pretty quickly. So you can get maybe a little bit more visual sense of where our current restaurant partners are on this map. And you can see we have, all of our restaurant partners. The Chipotle chains are colored this blue color, and the Panera chains are colored this pinkish color. We could edit those colors manually if we really cared. In this case, we don't really. So this gives us a pretty good visual sense of where our chains are. And you can see that we could, potentially increase the radius or decrease the radius to give us some sense of the geographic coverage of these areas. But the radius slider here is really just giving us a visual change. And if we want to work with this from a data perspective, we need to actually understand, how far away from each restaurant we can deliver. So the next thing we're going to do here is to define the delivery area. And we define that using a geographic function right within Studio. So a lot of the work we do here will actually happen right within Studio using the data we already have in memory. That makes it very fast and fluid. We don't have to continually go back and forth with Redshift, but we can go back to Redshift when we need more data or need to change our queries. So to create a new geospatial area for each restaurant, I'm going to move up here to the column panel. That's the second panel up here on the left. And I'm going to choose to add a column. And I'm going to call this column delivery area. As I said, naming things is always a good practice whenever you're doing some kind of analysis, because otherwise you can quickly lose track of where you are. It's as true here as it is in a Python notebook or any other analytical situation. And so to define the delivery area for each of these restaurants, I'm going to use the buffer function. If you've ever done any real GIS analysis, you might be familiar with this, but if you're not familiar with this, the buffer function is basically going to define a roughly circular area out from each point by a certain distance. So I'm going to buffer the latitude and longitude point. That's the center of my buffer. And I'm going to give it a 2-mile radius by typing in 2 miles. I think we also support kilometers and a few other units. And you can see down in this preview pane, it's given us a geographic area. This is defined as GeoJSON, and it's given us this new GeoJSON for each of our restaurants. So I'll hit create. Because we already have a layer for this data set, Studio will not automatically add a layer, but we have the ability to add that layer ourselves. So I'm going to go in here, I'm going to click the Add Layer button. And when I go to select a type, now we're not dealing with point data, we're dealing with polygon data. So I'll add polygons, and right away it chooses the only polygon field available, which is the delivery area we just chose, and we see that on the map. So now we have a delivery area that is well defined as a 2-mile radius around each restaurant. And that gives us a bit of a better sense of what our delivery radius might be and what kind of geographic coverage we have for these different restaurants. And you can see also pretty quickly that a lot of them overlap, especially right in downtown Atlanta. You might think that 2 miles is a short delivery radius for a food delivery company. You're probably right, but I think it'll make it a little bit easier for the analysis if we use a fairly short distance. And also, your food will be warmer and fresher when it comes from the restaurant. So the next thing I'm really interested in is I want to understand what the market is like in this area. And to do that, I can't really do that based on my chains. I need to do that based on some sense of the population and demographics in the Atlanta region. Before I do that, I'm just going to rename this layer for the same reasons I've been saying over and over again. So I'll name this delivery area. And then I'm going to bring in some census data that we offer for free as part of Studio's data catalog. So here I'll go to the data catalog. And what we have in the Studio data catalog is a wide variety of freely available, commonly useful data. A lot of this is around population and demographics, though we have a few other examples as well for things like where roads or streets are. The one that I'm going to use is this income data set, particularly because I know that this uses households. It gives us the count of households in various areas of the map. And I'll add this data to the map. Now, each of these data sets in our catalog is delivered as a hextile data set. And hextile is a proprietary data format that Foursquare has developed to deal with very large geospatial data sets in a way that's highly performant in the browser. So if you can see that it brought in a bunch of data around Atlanta. If we zoom out, it'll quickly load the rest of the data, and you can see the total extent here. So we have pretty fine-grained data for everywhere in the US, and you can go in and out fairly easily. As you zoom in and out, you get finer and finer data, and we can find the data in the area that we're actually interested in. One thing I noted earlier is that you can put layers. You can change the order really easily. So right here, I'm going to change the order to put the delivery area on top so I can see where I'm actually working here. And I'm going to turn off the original point layer because often you end up with layers that are not part of where you are in this given analysis. So what I really want right here is I want to be able to work with the population data around Atlanta. What we're seeing here in this income data set is the sum of total households, and that's actually the metric that I'm really interested in. And so what I'm going to do is I'm going to pull out the data around Atlanta to do a finer grained analysis just with that data, and that'll allow me to focus in on the population data I really care about. There are different ways we could do this, some with more or less rigor. What I'm going to do right now is simply to draw a polygon around the area that I want to pull out. So I'm going to roughly draw a lasso around my restaurants and use that to define the greater Atlanta area that we consider our current market. Once I have this polygon all set up, you can see I clicked on the beginning point again to close the polygon. It gives me this nice blue area of the map that I can now use for different kinds of analysis. The thing I'm going to do is I'm going to extract the data. So as you can see, I've got this gigantic data set of census-based income data. I just want the data for my area. So I'm going to extract this data. I'll pick the columns. I don't really need all these columns, to be honest, because we're not going to be doing a lot around income, but you can see how these might be useful for other types of analysis. So I'm going to deselect these and just keep the sum of total households. That's the number I really care about for this particular analysis. I'll hit confirm. I get a new data set name. We'll call this Atlanta households. And I'll hit extract. And it's added a new data set to my map. You can see it's colored a little bit differently because it is colored to focus only on the Atlanta region. And now that I have this, I don't really need the full hex tile data set anymore. So I'm just going to remove this to clean things up on my map. It'll remove the layer as well. Oops, I removed the wrong one. There we go. I'll remove this layer, and I can show you how to add data that I've already saved to my map, and that'll make things a little bit easier. So I accidentally removed the data set that I cared about. Let's get it back. I called this Atlanta households. Here it is. I used the add data button to get to this thing that shows me the list of my data sets that I have in the application. And I can now add this data back to the map. There it is. I might have picked one from an earlier version of this, which is why it doesn't match the polygon. Let's get rid of this polygon. It served its purpose. And if I go back to the layer panel, I can again put our delivery area above this census data so you can get a pretty good sense of how our restaurants align with the census data. Many geospatial applications stop here and say, well, you can see these things together on a map, and that's enough to do analysis. It's really not. What we really care about in Studio is the ability to do a bit more rigorous analysis by being able to join these data sets. So that's what we're going to do next. We're going to try to understand how many households we cover with our current data set. And actually, before we do that, sorry, what I did want to do first, I said we were going to talk about our total addressable market. We've basically defined our total addressable market using this rough polygon shape. And so we're going to add this. When we click on the chart panel over here, I can add new charts. One of the most useful ones is simply a big number that does some overall calculation based on your map. So I'm going to select a big number chart. I'll give it a name, total addressable market. That might even spell addressable correctly. And I'm going to select the data set I care about, which here is this Atlanta households data set. I'm going to select the sum of total households, the sum aggregation. I'll close that, and you can see now I have this number that shows me the total addressable market. So this is 2.36 million households that I could possibly be serving with my restaurant business. Again, there are lots of ways to define the total addressable market. This is I would say a rough and ready one, but it gives me actually a really good baseline view of how many households are in this area that I might eventually be able to reach. So next, once I have this sense of a total addressable market, the question is, how many of these people am I reaching already? How many people can I reach with the delivery radiuses that I've set on each of my partner restaurants? So these are all the places in Atlanta that I can reach. How many people are within that area? And to do that, I want to start doing a spatial join. So to do a spatial join, I'm going to pick this extract data set. And what I'm going to do is to join the count of restaurants onto this hexagon-based grid. I should have maybe mentioned this earlier, but the grid that you're seeing that's used to aggregate up the census data, this is called the H3 grid. It's a hexagon-based grid that we use widely in the Foursquare Studio product. And it's a really good way to give you a common unit of analysis for any kind of data you want to show on a map. It's very hard to deal with many different data sets and many different geographic formats, but the H3 grid gives us this common hexagon cell we can use in many types of analysis. What I'm going to do here is I'm going to take each hexagon cell here, and I'm going to count how many of our chain restaurants are available in that cell. I could do this in the opposite direction. I could do this by joining the population data to my restaurants, and that would tell me for each restaurant how many households it could serve. But I think in this case, it's actually going to be slightly more useful to go in the opposite direction and join the restaurants to the H3 data. So I'll pick a spatial join. For the join data set, I'm going to pick our other data set, the R chains data set. And it gives me this join operation. There are many different ways we could do a spatial join. For now, we're just going to use intersects, which means that if these shapes intersect, they'll be joined. And then when I look at the aggregation rules, I'm going to pick the aggregation rules I actually care about. So I don't need most of these columns. The thing I really care about is the number of restaurants. And to do that, I'll just take the name of the restaurant and I'll count it. So this will give me the count of restaurants that overlap each of these hexagonal cells. When I run this join happens right in your browser pretty quickly. And I can see I now have a new data set that has my the H3 ID, which is defines the hexagon. And then I have the sum of households, and I have the count of restaurants over that. You can see many of them are 0 because most of the data doesn't have a restaurant on top of it. And I'll hit confirm to create that new data set. Now I have this new data set here in my data set panel, and I want to make a new layer for it. It gave me a layer already, but it looks just the same because it has the sum of total households as its default view here. But if I turn off some of these other layers and I pick this count of name field, I'll see a different view. You can see right away that this different view doesn't give me as much information as I wanted. It's all one color, but we can change that. We have lots of different options for how to pick color palettes, not only the colors, but the way the colors are assigned to values. Jenks Natural Breaks is one that I like a lot. It breaks up the color spaces into areas that give you a nice definition between different chunks of your data. So you can see we get a pretty good view using the Jenks Natural Breaks color scale to see how many restaurants are in each area. And you can see we have some areas here where we have 7 overlapping delivery areas, and then we have some where you only have 1, and then the majority of the map has 0. No restaurants overlap those areas. So whenever I'm dealing with population data, and whenever I'm dealing with human created elements in some area, one of the things that's really important to me is to normalize my other data against population. And the reason I say that is because it's very easy to say you've got lots of restaurants here in the city center, but you also have lots of people. So these restaurants might actually be less valuable overall to your business than they would be out here where maybe there are fewer people and those people all go to this one restaurant. So to understand how to normalize our data, I'm going to create a new layer on our new data set. So I'm picking this, I went to the column panel. I'm picking the spatial join data set again. I'm going to add a column, and we're going to call that column restaurants per household. And I'm just going to divide the number of restaurants, which we still call count name. I could rename that if we needed to, but I don't need to in this case. I'm going to divide that by the sum of total households. And that's going to give me this normalized version of that metric that I can see on the map. If I go back to our layer panel, and instead of choosing the count of name, the number of restaurants we have here, I choose our restaurants per household, you get a very different view. And you can see that all of these restaurants right here in downtown Atlanta, these are actually only serving a small proportion of the households because there's so many people here. Whereas some of these other restaurants out in the suburbs might be potentially more valuable for our business. That tells me, for one thing, that there's a lot more room for growth in downtown Atlanta. I could add more restaurants here without competing as much with the restaurants I have there already. One other advantage of joining the restaurant delivery area to the population is that you can actually see where you have holes where there's no population at all. So this restaurant, for example, I have a delivery area, but most of the area here is actually not residential. And so that delivery area doesn't help me much. I would have to deliver much further from that restaurant to actually reach any households. So now we're getting closer to understanding our serviceable addressable market. What we want to know in the serviceable addressable market, just to reiterate, is we want to know the number of households we can reach just with the partnerships we have. So we're going to make a new column that's going to allow us to calculate this number. I'll go to the column panel. I'll pick the spatial join data set that we created, and I'm going to click add column. And I'm going to call this column serviceable households. This is the number of households that we can actually reach with our current restaurants. And to do this, I'll use what's called the ternary expression. You might be familiar with this. It's a 3-part expression. It says, I want to see where the count of name is greater than 0. I want to see the sum of total households, and where it's 0 or theoretically less than 0, that we shouldn't have any sub-zero values, I want to see nothing. And so what that's going to do is allow us to pull out the sum of total households only in those areas where we have restaurants. I can once again change my layer to use this new serviceable household measure. And now I get a different view where basically you can think of this as a mask if you're familiar with that idea. I can see the underlying sum of total households data only in places where I actually have a restaurant to service them. And now I can go over to this add chart again. I can create a new big number chart. I'll call it serviceable households. I'll select the data set that I care about, the spatial join data set where I just made that new column. And I'll select the new column I made, serviceable households, and select sum. And now I can see how many households I can actually service here. So just over 900,000 households are actually in my serviceable area. So if you look at the serviceable households and the total addressable market, you can see there's a big discrepancy here. I've got, you know, about 1.5 million, maybe not quite 1.5 million, but you know, 1.4 million approximately households that I can't reach with my current restaurant chains. So some may see this as a problem, some may see this as a business opportunity. This moves us on to the next part of our workshop, which is selecting new partner chains. So now everything we've done so far has been looking at our current business, looking at the partnerships we have already and the demographics and areas that they cover. What I want to do now is try to make a business decision. I want to find new chains to partner with that'll increase my service area. Now, there are lots of ways that I could do this, lots of ways I could think about this problem. I think in this case, the simplest one is I want to add new chains that are going to give me the most net new customers. So I want to add a new partnership, and let's say I'm just looking for one chain that's going to give me the most net new customers given their service area. So once again, I'm going to go to add data, and we're going to go to query to get this data out of our Amazon Redshift data set. And just to make sure this is, I've got the query right, I'm going to cut and paste it. You can do the same from this workshop page. But I'll walk you through it. So again, I'm selecting the name, the chain name, the latitude and longitude for each of these restaurants. And I'm selecting them from our sample table. And I want to find restaurants, but in this case, I've decided for the reasons of my business that I don't want fast food restaurants. Let's say we want to keep a slightly upscale tone for our delivery business. Fast casual might be great, but we don't really want to go down to the level of fast food. And so I want to keep the level of restaurants a little bit higher. So I'm going to exclude anything that has this label fast food restaurant. I want things that have a chain. So I'm going to say I don't want anything that doesn't have a chain name. And I don't want to include my current chains because I already work with them. So I'm looking for new chains that are in this category. I'm going to run this query. And now you can see I get back about 1,300 rows. And I've got these new chain restaurants that I might want to see on the map. And there's quite a few. So I'm going to add them to the map. Again, I've got a little bit of overlap here. So just to clarify the map a little bit, I'm going to hide this initial spatial join one. I'm going to once again label everything because I think that this makes things a lot clearer. So I have my new data set, which is the other chains that I might partner with. I'll call that other chains. And it gave me this point layer by default, and I'm going to call that other chains as well. And again, you can see, where they have coverage, and you can see that it covers many places in and around the greater Atlanta area. So again, I'm not just interested in the chain locations themselves. I'm interested in their delivery area. And so to get to that delivery area, I'm going to do another buffer operation, just the same as I did on our chains. So I'm going to pick this other chains data set. I'm going to add a column, and I'm going to call it delivery area. And then I'll use this buffer function again. So I'll buffer the latitude, the longitude. I'll give it the same 2-mile radius that I gave to my restaurants. And now we have this new calculated delivery area. And when I create that, I can add this to the map. I can either use a new layer, or in this case, I'll just change the layer we have already. I'll change it from a point layer to a polygon layer. It didn't pick up the GeoJSON by default, but I can select it here. I have this delivery area that I chose. And now I have my delivery area right there on the map. It's a little bit overwhelming. Maybe I don't need the stroke. Maybe that'll make it a little bit better. It chooses quantile by default, but because it's still looking at popularity. But again, I could choose something like name. Now I have lots of different values. So I want to choose a color scale that has many values and a color scale that has more of a categorical idea. And now I have maybe a slightly better picture of these new restaurants on the map where, you know, some of them are going to be colored the same when they have the same chain value. For instance, maybe these gray ones are Waffle House. Now, finally, what I'm really interested in here is understanding the delivery area, not only for a single restaurant, but for the whole set of restaurants in a given chain. And to do that, I need to group these new point restaurants, and I need to group them into groups where one group represents a single chain. So I'm going to find this other chains data set in my data set panel, and I'm going to go to group by, and I'm going to group by name on the assumption that chains have the same name. And I'm only going to keep the delivery area, and I'm going to aggregate it using not one of the numeric aggregations. I'm going to use this merge aggregation. And what this is going to do is it's going to merge the polygons for each of these delivery areas so that every chain will get one large complex polygon that represents all of its locations. I'll run that. I now have these different, this new data set, which is called group by name. I think I'll just keep that name for now. That's fine for the moment. And you know, it shows for each of these different chain locations, it gives me one geometry. I'll confirm that. I get that added to the map. I'll hide some of my other things. And it's a little bit hard to see unless I turn on stroke here. But if I turn on the stroke, maybe make the stroke a little bit larger, yeah. You can see that when I hover over some of these chains, I get multiple locations. This is going to be true. You can see the locations that I'm hovering over highlighted in yellow, and you can see now each one I hover over, I get all of the locations for that chain. So this is getting me closer and closer to what I need to use to determine how many new customers I'll get from each of these chains. So what I'm going to do is similar to what I did before. I'm going to do a spatial join with the new polygon data I have for these new restaurant chains, and I'm going to join that with my population data. So we're going to start by finding this group by data set that I just made and doing a spatial join. Again, we're going to use the intersects function, and we're going to choose our spatial join that we did before as our join data set. And again, I don't need all of these columns. The one that I really need is sum of total households, which I'll change to sum. And I also want the sum of our current serviceable households in that area. When I run this, it's going to do this spatial join. This will take a little bit longer than some of the other ones because the polygons involved are much more complex. We're dealing with a little bit more data. But eventually, I will get a data set that has the sum of total households and the sum of our currently serviced households for every one of these polygons, which represents an entire chain of restaurants. And it gives me a kind of long name. This name is a little bit unwieldy. Let's call this something more like households, other chain households. I'll hit confirm. It adds that to my map. Again, we've got a lot of layers here. We've got a lot of data sets. I'm going to hide some of the previous layers. And now for each of these chains, I have data about how many households they actually cover. And I have data about how many serviceable households they cover. So how much overlap do they have with my current coverage area? So the last thing I want to do here is understand the unserviced households, the households that these chains cover that I don't cover with my existing chains. And to do that, I'm going to add a new column on this other chain household data set. This expression is probably the simplest we'll do. We're going to call it unserviced households. And unserviced households is just the sum of total households minus the households that we're already servicing, the sum of the serviceable households. And now we have a number for the unserviced households for every one of these restaurant chains. There are a couple different ways now that we can narrow down on who's going to be the best. Probably the easiest is to add a chart. In this case, we'll pick a bar chart. We're going to choose the other chain households, and we're going to call this unserviced households. We'll pick the name of the chain, and then we'll pick the unserviced household metric we just made and the sum aggregation. And now we have this nice chart that shows us how many unserviced households each of these new chains would bring to our business. You can see that Waffle House is far and away the winner here. If we want to see just the Waffle House locations on this map, I can add a filter. I'll pick the other chain household. I'll select the name, and I'll enter the value Waffle House. And you can see we're adding a whole bunch. And if we want to understand how that measures up with our current delivery area, we can see our current delivery area, maybe drag it above the Waffle House area. And now you can see anything we see yellow here is going to be new delivery area that's added to our current business. And so Waffle House is giving us this really good opportunity to have a partnership with them. We clearly identified the best partner chain. If we can't manage to do a partnership with just Waffle House, we can look at other chains as well. So Marco's Pizza, Captain D's, IHOP, etc. These are all good candidates. And we can see exactly how many net new customers each of these chains will add. Waffle House will add almost 800,000. Marco's Pizza will add 400 and some thousand. IHOP would only add about 170,000. But that gives us a clear sort of opportunity size for each of these possible partnerships. So I would like to welcome Waffle House to the Door Eats franchise and wrap up our spatial demo. I hope this has given you a sense of some of the possibilities you can unlock using Amazon Data Exchange, Amazon Redshift, Foursquare's POI dataset, and Foursquare Studio. And I hope you get a sense of how you can use these different products together in a pretty seamless manner to answer a real business question, like who should I partner with? Thank you so much for your time. Please get in touch if you'd like to learn more about how Foursquare can work with you on this kind of problem. And I will turn it over to Uday to wrap up.
Awesome. Thanks, Nick, for this excellent demo and workshop. So let me see if I can share my screen. Okay. Right. So hopefully you all can see my screen. So now where do we go from here, right? Like what are the next steps? So I would say, continue to experiment with AWS Data Exchange and Foursquare data in your own accounts. You can also try out our other labs for AWS Data Exchange. We have a bunch of labs with different scenarios, and we can share a link for that in the chat as well. Which there's a lot more different use cases that you can try out AWS Data Exchange for. If you want to go deeper and do a deeper dive into AWS Data Exchange, or want to set up a session to dive deep into the capabilities, you can discuss this with your AWS account manager or solutions architect, and they should be able to help you. And if needed, they can also bring us in to dive deeper into your use cases. You will also find links to our upcoming workshops and webinars. So please do join us for those sessions as well. And finally, if you have any questions or specific data needs, please do contact us via the link provided. And as I had mentioned earlier in the beginning of the session today, the slides are available for you to download in the handout section of GoToWebinar. So you can download it and use these clickable links to get to the right place there. Finally, I would also like to share, that there'll be a survey coming out. So please do provide feedback. If you can take some time and provide feedback, that'll be super helpful, as that helps us to learn and improve as we run more of these workshops, in the coming months. With that, I want to thank all of you for joining today's session. Have a good rest of the day, everyone. Thank you. And we'll be around for another 5 minutes or so. If you have any questions, please feel free to ask in the question section. All right. Thank you, everyone.